The question is counting rooms, in which you'll be given with a map of building. Your task is to count the number of its rooms. The size of the map is in cross in squares. Each square is either floor or a wall. And floor is represented by a dot symbol and wall is represented by a hash symbol. And you need to find the total number of rooms and return that. So that will be the output and you have to return the number of rooms. So let's make it more clear. In the equation, basically you will be provided with an in cross in grid in which you have some cells with hash symbol, some cells with a dot. It is representing floor and this is representing a wall. And you have to return the total number of different components, like different disconnected components. Let me show an example. So can you identify like how many components are there? Yeah, there are two different components, like one is this and the other one is this. So you have two different components over here. Now how could you find that the different components? So let me show you a DFS call. Using the DFS call you can find this. So how would that DFS would work? So let's say we are at this point. We'll start from any available floor. So let's say now this floor is available, we'll start from this only. So we can move in 4 direction. So in the 4 direction, if we are moving to top, we'll be out of the grid. So don't move in that direction. As well as in the left and right, we have walls. So there is only one direction left, the bottom. So we'll move the bottom in and we'll mark this as the thread. So in this cell now, we can move to the right as well, the bottom one, as well as, no, there are 2 direction only. In the left, there is wall, so we cannot move in direct direction. And in the top, there is a visited one, so we cannot move in the top as well. So we can move at the right and we can move in the bottom. So let's say we are first moving to the right. So we'll mark this cell as visited. Now, after this cell, we cannot move anywhere because at the right, or we can say at the left, there's a cell which is visited. Or in all the 3 directions, there are walls present. So we cannot move in any direction. So we'll do a backtracking and we'll return to this cell only. After that, we'll move down. So this was available at that time. So we'll move to the downward cell and we'll mark this as visited. And again, we can move to only the leftward cell. So this is the left one and you have moved to the left cell and mark this as visited. After this, you cannot go anywhere because at the top, there is a wall. If you're moving to the left, there is out of the grid. If you're moving to the bottom, it is also out of the grid. And if you're moving to the right, then it's a visited one. So you cannot move anywhere. So if you're backtrack over this to this, then from there also, there is no more cell visit. There is no more cell to visit. So as you have visited all the connected cells, so this is one of the components. So you will break from over here. Now again, you will start your DFS call from the another available cell. As you have already visited this cell, so you will not start your DFS call from any of this. So from this available cell, you can start your DFS call. Let's say we are starting from here. So from here, we cannot move to any other cell because there are 2 walls and at the bottom there is a out of the grid. So we'll move to this direction only. So we'll visit this, mark this as visited. From this also, you will go to this cell, mark this as visited, again to this, to this, to this. Now you have already visited all the connected floors. So you can see in the 2 DFS calls, you have visited all the floors that were available, all floors in 2 DFS calls. It means you have 2 different disconnected floors. Like this was one connected floor only and this was one connected floor. So you have 2 different connected floors. So your answer would be 2. So in that way, you have to return your different components. So let me show the code and it will be more. So what we have to do in the question is first get the input in the name. There is a number of rows and number of columns and initialize the answer with 0. As well as we will take a string. For each and every row, we will take a string as an input now and we will assign this in a grid. So we have declared the grid which will store the character only. That's a dot or a hash. And we have also initialized the visitor with a 0. Because if we are visiting any particular cell, we'll mark it as 1 and initially it would be 0. Now we are taking the input with a string s and we are just pushing the character. It is a dot or a hash in a grid. So our grid is a 2D vector in which we will have that dot or hash. Now we are traversing through the grid. If that is a available floor, it means it's a floor and it's not visited. It's not visited, it means it's available floor. So we'll start traversing from this particular cell, and we will also increase our answer because this cell is available and it is a floor. So it could be one of our answer. So we are just incrementing our answer and we are calling our DFS to start from this particular row and whatever cell it can go, like through the connectedness. So we are calling the with I and J, that is the row and column, the visited as well as grid. We have parsed it. Now, as we are visiting some particular cell, we'll mark it as visited. We'll mark it as visited, and we have to move in the four direction, like the top, bottom, left, right. So we have just declared the direction over here, -1, 0. So 0, -1 is the top, and this is row +1. So it's a bottom one, second one, and the third one is to the right, and the last one is to the left. So using that four direction, we are just calculating our new cell. So if the new cell is valid one, like it's greater than equals to 0, as well as it's within the grid. If it is within the grid, as well as it's not visited yet, and it should be a floor because we can move to the floor only. If it is a wall, then we can move to that particular cell. So if it is a floor and it is connected to the current cell that I am standing on, so we can move to that particular cell. So we'll move to that particular cell and we will again mark that as visited. Again, we'll move to some connected cell from that particular cell, like new row from new column. We will move so on and so forth. We will move until there is no available cell which is not yet visited. And as well as it's a flow. So we'll move until that point, and after that we'll return, and all the connected flows from this particular ij will get be visited now, because we are starting from ij. So all the flows that are connected from ij and which are not yet visited will get visited now. So again we'll go for another non-visited flow and we'll traverse for that particular cell now. So by this way we'll get our all the connected flows, like all the different connected flows we'll get our in our answer, and we'll at the end print that answer only. So that's it. I hope it's clear. Thank you for watching.